All right. Welcome to day 3 of our penultimate week of statistics. So again, this week is taking what we learned about the central limit theorem and combining it to what we were trying to figure out about confidence intervals and hypothesis tests. Last couple of days, we did a bunch of confidence intervals. Today, hopefully some of the questions are about hypothesis tests. And for most problems, you can either use stack heat or spreadsheet formulas, or there's some TI videos in here based on the book and another friend of mine who likes the TI. If any of you have one of those, I don't have one and I don't particularly care for them. I think spreadsheets are better, but anyway. Final exam is next week. The big things this week are getting done. There's basically just 2 practice sets, the one I call review and the one I call application. The applications are just a little harder. More detailed. And then the final notes is where you're going to write up, and this is super important. This is what I did as a college student. I always took my notes from the quarter and I tried to summarize all the important facts, formulas into like 2 pages if I could. And then that is what I kind of focused on in redoing old problems, getting ready for a final. So I asked that you do that and then take a picture of your notes, or if you have them typed up, sometimes I would type mine up, I'd get fancy, but usually they were just handwritten notes. Post them here, and we'll be able to see each other's notes. So take a peek at what other people did and say, ooh, yeah, I missed that formula. I should put that in my notes. And you don't need to comment on each other's. It's just there to kind of share what each of us think is important in getting ready for the final. The other important thing about that is not only like cementing in your head the stuff that we know so far, it's an organized set of notes that's going to help you more efficiently take the final exam. If you're just kind of randomly searching through the book and searching for key terms online, that's going to take more time and diminish the amount of time you actually have to work on and think about a particular question. So this critical thinking exercise is going to just help make taking the final more efficient. The questions on the final exam are like the questions on the practice final. Some of them are even identical. So take this practice final, do each question more than once. Definitely get 100% on the practice final before you dare take the real one. And although the practice final is due Tuesday of next week, try to get it done before then. And the final exam will be available next week, Monday, Tuesday, or Wednesday at any time you choose from home or wherever. There's no proctor, no ProctorU. It's just you and the exam in an hour and a half's time. So make sure you're well rested and fed, and you have your nice, clean, quiet space to work in, and that is vital. So get help from your family to make sure you have that quiet time you need to take that when you're ready for it. And so you have up till the end of the day on Wednesday. Please don't wait till 11 o'clock Wednesday night to take it. That would be a bad idea, right? Take it way before that. But anytime on Wednesday is actually fine. The reason it's due Wednesday is the quarter ends on Thursday, and I'm supposed to have my grades done on Thursday. And you all know how slow I am at grading. So that's going to be interesting as usual. All right, let's do some, let's see, is there anything else I want to say about that? Oh yeah, the other thing about the final exam is there's on each question, there's an add work button. So on Monday morning, I'll release the password and you can type it in any time you want. Once you type the password, however, this clock starts ticking. So don't put the password in until you have that 1.5 hours to yourself to do it. And then I do expect you to submit work, right? I tell you all the time, write stuff down on paper, put it in a spreadsheet or your calculator. Anything that goes in your calculator should be on paper first. If using a spreadsheet's kind of like a notebook and a calculator all in one. So then either at each question, you could add your work to that question, or just at the end, add work for all of the questions. And when you do submit work, make sure I can tell which question is which. So you might want to label it. This is number 1 and this is number 2. But if it's just a scattered, messy piece of paper, that wouldn't be useful for me when I'm trying to figure out when things went wrong for you. So the point of your work is to make sure, like if you don't get something perfectly right, that I can look at your work and say, oh yeah, they deserve some credit for this, even though it's not completely right. All right, work time. So let's see the chat. We've got problem number 10, application. Okay, so app 10, and then app 8, the p-value. Yes, p-values are a challenge. Okay, and then 10 and 12 inferential statistics. Which one is that? That would be the, Mercedes, is that the review or the application 10 and 12?
It's the inferential statistics review.
Okay, so that's the first one. All right, so review
Yeah.
10 and 12. Thank you. And then Charlotte still has a 0 on your application 7. Yes, Charlotte, I am sincerely sorry. I'm as slow as ever, even though I'm trying to be faster. I got, let's see, a couple of days ago, I finally finished application 6 for everybody. Last night, I got through about half of application 7, and I'm going to continue to grade those today. For the most part, they were really good. Like for the first time in a while, like the first 10 I graded, I think were almost perfect. So I'm going to continue to work on those today. I am hoping to have everything, including extra credit and any corrections people gave me, done by Saturday, so you can kind of go into the final week knowing about where you sit. And again, I'm sorry I'm such a slow grader. I'm just slow. So let's see. I'm gonna do the review 10 and 12 toward the end, I think. And then, because I actually did those in the last 2 days also. And yeah, so those of you who didn't get a grade on application 7, I'm sorry for keeping you anxiously waiting.
Are you going to record this session?
It is being recorded right now.
Oh, okay. I just
Yeah.
don't see the little red record thing.
Well, let me double check. Maybe I messed up.
Oh, just kidding. My bar was over it.
Yeah, okay. Yeah, it's hard to tell. Yeah, so mine does say I am recording right now. So we have 5 minutes, 10 minutes of me rambling, and now we're actually going to get to work. So I'm going to go for application number 8 first. And I try to set these up in this section where I tell you what we're doing and I give you formulas that you might need for the questions that we're doing. The actual test is a little bit different. I don't necessarily give you the formulas here, but I do say, hey, these are confidence intervals for a proportion. Hey, these are confidence intervals for a mean. I try to clarify which thing you're currently working on in the final. So there are some prompts. Number 8. Okay. Test the claim that the proportion of people who own cats is larger than 70% at the significance with a 0.1, a 10% significance level. So again, reminder about a significance level. Significance level is the probability of making a type 1 error. And a type 1 error is where we reject the null hypothesis, but in reality, the null hypothesis was true, so we made a mistake. And that's the problem here. We never know if we're making a mistake or not. We just hope according to the probabilities we're throwing around. And the 2 significant probabilities we need to pay attention to, the significance level is 1. So this is a 10% significance level because who really cares about who has a cat or not? But if it was something more important like a medication or amount of pus in our cow milk, then we might drop the significance level to like 5% or 1%. And then the p-value, that's the really important thing. The p-value gives us the chance of finding another sample like ours, or in this case, larger, where it's, did I say that right? The probability of finding a sample like this with a proportion of this or bigger. And if that p-value is too small and we know our sample is good, that means the null hypothesis is probably wrong, is the way that works. And so that's our real evidence to reject or fail to reject. Significance level is just somebody's opinion, which isn't necessarily as important. Okay, into the notebook we go. And let's see, I really only need this much of it. And add to current, please.
I just want to make sure that you understood my problems right. It is from that same assignment that you're working in, the 10 and 12 from that assignment.
Oh, it's in the applications, not the review?
Yeah,
okay.
on my grade book, it says it like that though, the way I typed it on the note or on the chat.
Okay. Got it. All right, so magic pen on. So the first thing we have to do is figure out what the claim is here so we can identify, uh-oh, my magic pen turn on. Oh, battery issue. Sorry guys, hang on again. Emergency power cord, where are you? Uh-oh. It's not in its usual spot. Where is it? Eek. Okay, I'm just gonna hope and pray for a little while that my pen doesn't die. So test the claim that the proportion of people who own cats is larger. So larger is the key word there, and larger means greater than, not greater than or equal to. Since this doesn't have an equal to in it, it must be the alternative hypothesis. And then we always state the proportion not as a percent, but as a decimal. And this is a proportion means it's a p, not a mu. It's not an average, it's a proportion. So this is my alternative hypothesis. So I'm just looking for any one of these that has that, and there should be only one. And on mine, it's this one right here. So I would check that box right there because it says the proportion for the alternative is greater than 70%. And then the null hypothesis could either be an equal to or a less than or equal to, and here they picked a less than or equal to. So the claim you get may be the null hypothesis, but it may be the alternative. It just depends on the presence of an equal sign. So that's a greater than on the alternative. The alternative decides the test, so this must be a right tail test. So I would select that. So quick picture here. So I hope you're drawing pictures all the time now. The null hypothesis value is what goes in the middle for a hypothesis test. So 0.7 is the center of my distribution here. And let's see, what else am I gonna need here? I'm gonna need the standard deviation, standard error for a proportion, and that is P times Q over N inside the square root. And that tells me what the spread is, how far 1, 2, and 3 standard deviations is on either side. And then this right here, based on a sample of 100 people, I have 75% own cats. So that tells me right there that P prime is 0.75, N is 100, and I'm going to use the central limit theorem instead of stat key here, I think. So continuing along, let's get out a spreadsheet now. And that should be this sheet, should be a good one. And this is application 8. So we need a new tab. Oh, hit 2 new tabs. And you could also use, if you want, those pre-made spreadsheets that are in this section and just plug in the numbers you get. So that's another option here. So I have a proportion, own cats. I have the null hypothesis, which is P, I'm just gonna say P equals 0.7. And I have the alternative, which is P is greater than 0.7. Significance level, I'm not too concerned about, but I'll put that in here. That's alpha. And in this case, alpha for me was 10%. Let's see, what else do I need to know here? So that's the information about the hypothesis. Then we have the sample information. And for the sample, we've got P prime is 0.75. Let's see, I don't need Q prime here, but I do need N. N is 100. Up here, however, I do need Q. So P and Q are from the population. P prime and Q prime are from the sample. So that's going to be 1 minus the null. Okay, and then I need the standard error. So that's about the sampling distribution. Standard error. And that's that funky square root, SQRT of P times Q divided by N. So in some kind of calculator, you want to put that out there. And that's just the standard deviation of the distribution of distribution of proportions. That's another way to word that. Okay, once we have that, we can do the p-value. And I'll also have Stackey draw this because it does good drawing. So I got my own drawing. Who needs Stackey today? But I'll do it anyway in a minute. So the p-value is the probability of finding another proportion, so p prime, that is bigger than my sample, 0.75, when I was expecting it to be more like the population, which is 0.7. So that's the probability we're going to try and calculate. And if it's really small, we can say, oop, null is wrong. Our sample depicts another reality. So what was my standard error? I need that. It was about 4.5%, 5%-ish, somewhere in there. Oops. Here we go. So, so one standard deviation to the right is, what was it, 4.5%. So then this right here would be about 74.5%. Oops, extra decimal there. So 0.745. And I wanted to know that so I could see roughly where the 75 sits. And if you have a hard time figuring that out, Stackey will do it for you if you give it this number. So I could show that too in a sec. So I would say right about here is where the sample P prime lives, 0.75. And my alternative says it's a right tail test, so I want to know what this area is out here. So that's my p-value. For a proportion, a p-value on a spreadsheet is a norm dist. And the norm dist needs to know what's the value on the x-axis. Well, that's my p prime here. And then it wants to know what's the mean for the distribution. And in my picture, I drew 0.7, the null hypothesis. So that right there is p from the null. And then it wants to know what's the standard error for the distribution. And then it wants a 1 or the word true. I usually like to put true there, which means pretty much add stuff up. Now, because the norm dist only does left tails, so since this is a right tail, I have to tweak it by doing a 1 minus, which flips from the left side to the right side, because all of the probability has to be 100%. So I'm going to do a 1 minus a norm dist, and then I'll have Stackey double check with a picture. So back to the spreadsheet. And again, you could use that other spreadsheet I have that has all this already in it, where you just type your numbers. So this is a 1 minus the norm dot dist, because it's a right tail, and then it wants my sample data, comma, the mean, which is the null hypothesis value, comma, the standard error that I calculated, that funky square root, comma, and then true. So this would be something you want in your notes if you think you're going to use a spreadsheet. So I'm getting about 13.7%. That's definitely higher than the significance level. So this implies I should fail because it's such a large, p-value, p-value. And if the p-value is too big, that implies fail to reject. What that means is your sample data is close enough to what was previously believed that it's about 70% or less. So it's close enough in this context. Stat key to double check this, because it will draw a nice picture for us and better identify where that 75% goes. This is a theoretical normal I'm going to apply here, kind of like I was doing in the spreadsheet. The norm dist is the theoretical normal, and we need to edit our parameters. So it wants the null hypothesis, oops, and then the standard error. So on my spreadsheet, I calculated that, so I can just copy and paste that in. And then I get all the decimals. and okay. So then it redraws it, and I got lucky, it put the 70% in the middle. It doesn't always do that. The labeling on the bottom, I mean, is always, you never know what you're gonna get. Right tail test. And here we can see the 75% is about where I was thinking it was in the picture. So then I just go down here and put my sample data, and it's the sample data that tells you your p-value. And so I get 0.138, which should match what the spreadsheet said. Yeah, to the nearest, the third decimal place, right? To the nearest thousandth. Yeah, so StatKey agrees. Reminder about screenshots. You're probably gonna want to include some screenshots in your work. So to take a screenshot on a Windows computer, it's either the snipping tool or Snip and Sketch is the new version. So it depends on your current version of Windows. If it's an older one, it's Snipping Tool. If it's a newer version of Windows, then you have Snip and Sketch. And they both work about the same way. You got to make sure you have what you want to take a picture of in the background. And then in Snip and Sketch, you just hit New. And then it wants you to just draw a rectangle around what you need. So maybe I just want this part of the graph. And maybe I want to show the mean and standard deviation, but on my screen, it's showing pictures of you, so that's covered up. So I'm going to skip that. And then if I want to use this somewhere like Canvas or the homework system that we're using, then I would have to save it somewhere, give it a name I'll remember, and then I can upload the saved picture. So this is cats hypothesis test. And so if I wanted to stick it in my spreadsheet, I just pick a place, insert, and then image. Oops, my Zoom stuff is covering. No, stop it, Zoom. Shit, sorry. I lost it. Oh, there it goes. Insert, image, overcells. And I did a video about this in like the first or second week of the class. Cats hypothesis test. I can stick it in there. Bang, there it is. Okay, so there's a picture of the thing I just calculated, which relates to my hand-drawn sketch. So we're gonna fail to reject here. Okay, so see if it likes my p-value. 4 decimal places, 0.13, I think it was 76. So StatKey only gave me 3, so it would probably object to that if I tried to do the 8 there. Let's just see. Oh, it took it anyway. Cool. All right, but again, it depends on how close that actually is. It should have been a 7.6. All right, I'm gonna pause the recording and start a new one.